Welcome back to my YouTube channel. Today we'll be looking at a problem on second order Runge-Kutta method, and we'll be using the second order method to solve this system of ODE. Okay, so looking at the question which says use the second order Runge-Kutta method to find an approximate value of y, given that the y dx is equals to x minus y squared and y of 0 is equals to 1 at x equals 0.2, taking h to be 0.1. Very simple. Like I do say, the first thing you need to do is to list out your parameters. So given that the y dx, which is equal to x minus y squared, you need to know that f is a function of what? X and y. So also, we remember that y of x naught is equals to y naught. So from the question, we say that our x naught is equals to what? 0. And our y naught is equals to 1.
Okay, so you are trying to tell us here that our dy dx, which is x minus y squared, is just a function of x and y.
Yes, it's a function of x and y.
That's why you wrote this one.
Yes, that's why I wrote it there. So we also know that we have our x to be equals to 0.2, and we have our step size to be what? 0.1. So we need to find out what? Our step number n, which is equals to x minus x naught over h, if you can remember vividly. So our x is 0.2 minus x naught, which is 0, over h, which is 0.1. So this will give us 0.2 divided 0.1, which will give us 2.
Okay, so you got this x naught, which from this formula, comparing this formula with this,
Yeah.
y x naught x naught. So our x naught is equal to 0 here.
Yeah, the y naught
equals
is
to y
equals
naught.
to
Y
1.
naught is equals to 1. That's
Yeah.
how you arrive at this. Okay. Why this is the formula for n itself?
Yeah, for calculating step number.
Okay.
So having known that our step number is 2, you know that we have to do 2 approximations for this example. So now, having known this to be 2, we now say we look for x1. From our formula, we say x naught plus h, and your x2, which says x naught plus what? 2h. So our x naught, which is 0, plus our h, which is 0.1, which will give us 0.1, and our x naught is 0 plus 2 into 0.1, which will give us 0.2.
So why do we have x1 and x2? What are we trying to do?
We have two-step numbers. So that is to tell you that for your first approximation, you have to calculate it at x1 equals 0.1. And for your second approximation, you have to calculate it at x2 equals 0.2.
So just one more question, sir. Which one is approximation? Or can you tell us another name for that approximation?
When we talk about approximation, I said I personally use it as first approximation, second approximation, but in some other materials or some videos, you can hear it as first iteration or your second iteration. So now that you've known that your step number, the number of steps you need to take, is 2, that is to tell you have to do first step and second step. Okay. So for you to do your first step at x1, you do your first step at x1, and you do your second step at x2. Okay. So now we say our first approximation at x1 equals 0.1. Remember, k1 is equal to hf x naught comma y naught. So the value of h is what? 0.1, right? Then now function of x and y, if you can remember, what is x naught? X naught is what? 0, right? Y naught is 1, right? So we are going to say we have 0.1 into, now what does our rule say? Our rule says what? X minus y squared, right? Yes. So value of x is what? 0 minus what? 1 squared.
So how come about this k1?
K1 implies first order Runge-Kutta.
Okay.
K1 implies first order Runge-Kutta. Since they said we should use second order, we are going to be stopping at what? K2.
Okay.
So now we are still solving for K1. So if we use our calculator to do this, our K1 automatically becomes minus negative 0.1. So K2, which has the formula of HF of x naught plus h, comma, y naught plus K1. This is for second order
Okay.
Runge-Kutta. This is the formula guiding second order Runge-Kutta.
Okay.
And we now say our h is 0.1. X naught is what? 0, right?
Okay. Yes,
Plus 0.1, comma, y naught is what? 1 plus K1 is negative 0.1. So now we can now say our K2 is equals to 0.1, right? Into 0.1, comma, 0.9. If you use your calculator, then if you now apply the derivative, we are going to say 0.1 into x is what? 0.1 minus 0.9 squared. So when you use your calculator, you are going to get negative 0.071. So this is your K2.
Okay.
This is your K1.
Okay.
So since you are being told to use second order, what you just need to do next is to find a value of y, and y1 says that y naught plus k, right?
Okay, so what does y stand for now?
Y1 is to tell you that since you are calculating first approximation at x1, you have to get y1, right?
Okay.
So y naught is given in the question. Now k is not given, and for you to get your k, where k is equal to 1 over 2 into k1 is k2. So this is where it becomes more interesting. So we now say k is equal to 1 over 2 into negative 0.1
Okay.
plus negative
That is our K1.
0.071.
K2.
So a value of
K2.
k will be given as, you use your calculator, negative 0.0855. So we can now substitute back into y1. So y1 is equals to y naught plus k, right?
Yes, sir.
So that will be equals to y naught is 1
Okay.
minus, sorry, plus negative 0.0855. So y1 will be equal to what? 0.9145. So that is the value of your y1 at x1 equals to what? 0.1.
Is that all?
No, that's not all. We are told to do how many steps? 2. So we've only done 1.
Okay.
So you say our second approximation following same method at x2 now, at x2 to be what? 0.2.
Okay.
So you see our k1 this time around is hf x1, comma y1. So we are going to have this as 0.1 into, now what is x1? X1 is given as 0.1, right?
Yes, sir.
X1 is 0.1.
Okay.
Then y1 is what we just got as 0.9145, right?
Okay, sir.
So applying our derivative, so 0.1 into x,
Y square.
x, which is 0.1 minus y square, which is 0.9145 squared, right?
Yes, sir.
So our k1 will equal to, after you use your calculator, we have a negative 0.073. 36. So that is K1.
Okay.
Then your K2 formula still remains HF x naught plus H, comma, Y naught plus K1. So you are going to have this as 0.1 into x naught plus H, which is x naught is 0 plus H, which is 0.1, comma, then Y naught, which is 1, K1, which is negative 0.0736. Okay, so our K2 will now give us 0.1 into 0. This is going to be, oh, okay, now pay attention. There is a mix up here. I said K2 is equal to HF. Is this supposed to be X naught? No. This is supposed to be what? X1.
Okay.
Why this is also supposed to be what?
Y1.
Y1.
Okay.
So X1 is 0.1. 0.1 plus 0.1. While Y1 here
0.94.
here should be 0.9145 plus negative 0.0736. So please pay attention to that correction. So we are going to say we have 0.1 and now 0.1 plus 0.1 will give us 0.2, right?
Okay.
Then 0.9145 plus times minus will give us negative, right?
Yes, sir.
So we say 0.9145 minus 0.0736. So that is going to give us 0.8408 when I use my calculator. So my K2 now is going to give us 0.1 into, now we say 0.2 minus.
Okay, now we are applying this.
You are applying the derivative now.
Okay, our H is
0.8408
y
squared.
squared. Okay.
So you see our answer for K2 is going to be negative 0.0736. So that is your K2. Then remember that K is equal to 1 over 2 K1 plus K2, right?
Sorry, sir, I need to get something, sir. Because from these equations, it is y raised to power 2. Is this y not the same thing as y1 here?
Okay, I think there is another mix-up here. Please
Really?
confirm this value for me. Confirm this value with calculator for me.
Okay.
So after using your calculator, I think the value we got initially was wrong. After using your calculator, you should get your K2 to be equal to minus 0.0507. So sorry for the mix-up. So take note of this. That's the value for K2. Then you also need to remember that K is equal to 1 over 2 K1 plus K2. So you can say your K is equal to 1 over 2 into your K1 is negative 0.0736 plus negative 0.0507. So your value of K should be negative 0.0622. So now we can now find your Y2, which is now equals to Y1 plus K, which is the standard for second order. So you see your Y2 is equal to 0.9145 plus into negative 0.0622. So your Y2 is given as 0.8523 at x2 to be equal to what? 0.2. So that is your final
So this is our final
answer.
Okay. So viewers that are watching, please do well to comment, share the video with your friends, like the video, and thank you. See you in our next video. We have many other videos on other courses so far using Euler's equations, using power series, and so on. Do well to check our channel. Thank you very much.